Myself, Mr. Balamurugan, Department of ACE, K.S.Rangasamy College of Technology. Today, I am going to discuss the topic was wireless sensor networks design principles. First of all, we need to focus on the wireless sensor networks. We have the sensor is a measure of electrical quantities. That quantities how they're going to share of information to the cloud or to the control unit. The networks are spatially distributed. It is an autonomous sensors. It is an automatic sensors automatically detect the electrical quantities and that will be distributed spatially to the networks. The sensors in general to monitor the physical movement or physical activities and environmental conditions like temperature, motion, sound and pressure. Temperature sensor, motion sensor, sound sensor, pressure sensor at all. And what are the applications in wireless sensor networks in general? In environmental monitoring, smart homes, military applications, industrial automations. And what are the challenges have been faced in wireless sensor network design? We have severe resource constraints. It is a limited battery power. The battery power is the major one, and processing and the focus on memory. The memory plays the vital role for designing an wireless sensor networks. We have three constraints: battery power, processing, and memory. And harsh and unattended deployment environments. Here the communication, it's not for the reliable communication. The noise is added to rectify the noise, whereby it deals with a unreliable wireless communication and a dynamic network topology. We have different type of topologies, star, ring, bus, different type of topologies. For their network topologies, it is dynamically, automatically adopt their topology and share of information. Thereby, another challenges is that need for self-organization and fault tolerance. For this slide, we focus on the design principle, the scalability and flexibility. What about the scale? What about the flexible? The networks must support hundreds to thousands of nodes. A collection of nodes to share of information through collection of nodes said to be the networks. Therefore, the WSN wireless sensor network, it is to share of information in terms of thousands of nodes. And architecture adapts to adding or removing nodes of without disruption. For example, hierarchical clustering, the cluster data to manage large-scale deployments. And we focus on the design principle. Another parameter is power efficiency. The power efficiency, the sensor nodes are limited battery energy. Thereby, if it is possible to replace using an automatic battery charging, the replacement often it is impossible. What are the techniques? Duty cycling, energy efficient routing. The routing is going to identify the route path. The power aware of MAC protocols, media access control protocols. Now let me tell about the reliability and robustness. Now the reliability, the nodes to failure due to environment, the rainy season, winter season, so different aspects, the nodes to be failure or energy to be depleted. The design for redundancy. Redundancy stands for error. CRC, cyclic redundancy check, different redundancy codes and fault tolerance via multipath routing and data fusion. Here, they are going to ensure continuous data collection despite node failures. What about the network architecture and communication protocols? So here, the distributed technology, the distributed architecture, a unified architecture, and the communication should be a data-centric communication rather than the address-centric, a cloud-centric, a server-based. So we are focused on wireless sensor network or the data-centric communication for the server-based communication rather than the address-centric. What are the protocols behind to the layer protocols? Physical layer, media access control layer, network layer, transport layer tailored for wireless sensor network constraints. Not about the examples, it is a location-based routing protocols to reduce the overhead and improve the efficiency. And we focus on the next part is the adaptability and application-specific design. So WSNs must adapt to changing the environment. Depends on the climate condition. The sensor have to adapt to changing the environments and application needs. The custom sensor like fire detection, logistics need to be worked properly to adapt their environments. So custom sensor don't design in software for specific tasks like fire detection and logistics. The integration with IoT platform plays the vital role for enhanced functionality. Now we focus on the future of what are the future needs for WSN design. The advances in energy harvesting. Plays the major role in order for energy harvesting and ultra low power electronics is needed, and also focus on the security frameworks for IoT integration, and it's growing in smart cities, environmental sustainability, and industrial automation. Thereby, the WSNs is the multidisciplinary challenges have been faced. Blending in hardware and software and network is needed. So, thanks for patient listening. Thank you.